Hi everyone and welcome to round 1 of 2017. As I've said in my previous videos, if you want to gain access to the code that I use in these videos, just go to the GitHub link in the description and you can find all the answers to all the rounds and years that I've covered in my videos. So without further ado, let's get started with question 1. So in this one we are just asked to calculate the end of investment amount using simple interest. And so as input we're given the initial investment P, the interest rate in percentage, so it's actually 100 times bigger than what we're going to use in our calculation, and that's going to be R, and then the time in years, which is T, and A will be our output value. So we're going to declare our three doubles because they can be of floating point value, so it will be P, R, and T. We're going to extract them from the input stream and then declare A, which, like I said, was the end of investment amount. And then we're just going to copy this formula over into our code. And so the end of investment amount is the initial investment plus the initial investment multiplied by the interest rate, which, like I said, is R divided by 100 because they give it to us 100 times bigger than we actually want, and multiplied by T, which is the number of years. And then as our output, we're going to set it to fixed because by default scientific if you're using doubles, and we don't want scientific notation to represent our output. And we set precision to 2, which rounds the decimal to 2 places, if that makes sense. Right. So let's test some of the input values or test cases. So we're going to start with 5,000, 12, and 5. We get 8,000. Now if we try 3,750, 7.5, and 10, we get our desired output. And you can test these other test cases, but we should get the right value. So for this next question, we are asked to output the nth item in the Fibonacci sequence. And the Fibonacci sequence is very similar to the Fibonacci sequence, but instead of adding the 2 previous elements, we're adding the 3 previous elements. So as input, we're given the 3 first elements of the Fibonacci sequence, and then we're given the value n, which is the item in the Fibonacci sequence that we're going to output. So all we do is we declare 4 integers, a, b, c, and n. A, b, c will be the first 3 values of the sequence, and then n will be the item that we're looking for, the position that we're looking for. And then we just declared an array of integers titled Fibonacci, and it's going to have n elements. And then we declare the first 3 indexes to A, B, and C respectively. Then we're just going to go through a for loop, and then starting from 3, and we set Fibonacci at I to Fibonacci at I minus 3 plus Fibonacci at I minus 2 plus Fibonacci at I minus 1. And then we're just going to output Fibonacci at n minus 1. And if you're confused about that, this is because of this. So let's just say that our first 3 items are 1, 2, and 3, and we're looking for the 6th item in the Fibonacci sequence. So this is just the Fibonacci sequence, and it's going to have 6 elements in this case. So it would look something like this. So 6 would be these elements added together, then 11 would be these elements added together, and 20 would be these 3 elements. But you can see that it's indexed from 0 to 5 as opposed to 1 to 6. So if we're looking for the 6th item, it's going to be n minus 1. Actually, yeah, let me test a couple of test cases. So start with 1, 1, 1, and 5. Yeah, so we get the desired output. Now we're going to try 2, 3, 4, and 10. We get 335, and I'll test the largest test case, and I'll show you how large these numbers can get. 15, 16, 17, 33. So yeah, we get this huge value. I mean, that's like, what, a trillion? Yeah, I think so. Or, 2 trillion, whatever. So that's it for this. So then for this final question, we are given text as input, and we are asked to output the average word length in this text. And so let's look at how we're going to implement this. So we first declare our input variable text, which is going to be of type string, and then we initialize the number of total letters and total words to 0, and then we're going to also declare our output, which is going to be of type double, since we have floating point output, and we're going to call it average, which is intuitive enough. And then we're going to use the getLine procedure to extract the text from the input stream. And now we're first going to calculate the number of the total words inside of the text. So we're going to start from I equals 1, so from the second letter inside of the text, or the sentence if you prefer. And we're going to go up to the last character or letter, whatever it is, inside of the text. And so we're also using this is_alpha function here, which I'll explain now. Now, it's actually built into C++, but I made it by mistake anyways, because I don't know it was there. But all it does is it just returns whether it's a lowercase or uppercase letter. So if any of these are true, then it returns true. So if the text at I-1 is, off from the alphabet, and the character at the current position isn't of the alphabet, then we increase the total words. So for example, if let's say we are on this character, I equals this character, which is a space, and so this character before is of the alphabet, and the current character isn't, so we add, or we increase the number of words. And if we come to the last character of the text, it'll be some kind of punctuation mark. So we'll have an alphabetic, or letter of the alphabet before, and then we'll have a character that comes after that's not of the alphabet, and we'll increase the number of words. And that's about it for the total words. And then we're also gonna the total letters is a bit simpler. We're just going to cycle through each character inside of the text, and we're going to check if it's of the alphabet, and if the character is of the alphabet, then we increase the total letters by 1. And the average is we're going to cast, first of all, total letters to double, so that when this is divided by this, we get type double as an answer, because integer divided by integer gives us an integer, or it's type double flawed. But we want to make, double divided by integer or integer divided by double gives us a double value. So we can cast either one of these to double, and we'll get a double value as a result, and then average will store that floating point value. Then as output, we just set it to fixed, because like I said before, scientific is default, and we don't want scientific notation as the output. And we set precision to 2, as in rounded to 2 decimal places, and we output the average. And that's it for this. Let's test some cases. These ones I'm gonna have to put on a single line. We get, oops, why is it not working? Oh, there you go, 4.17. And that's the final solution for this. Anyways, I hope that was helpful, and I'll see you in the next one. Cheers.